In this video, we're going to learn about another thing that you can do with vectors. And this is specifically something we're going to do now that we have the component form for vectors. It wouldn't really make a lot of sense if we just tried drawing arrows and tried to calculate it that way. So let's go ahead and talk about what the dot product even is. We're going to take two vectors. My first vector is going to be AB. My second vector is going to be xy, and we are going to put a little dot between them. So in this case, we're actually multiplying two vectors together in some way. It's not going to be the way you probably expect, though. You might think, based on how we've previously done vectors, you would just multiply the first components, multiply the second components, and that would be your answer. But it turns out that is absolutely not the right way to do a dot product. It's a very common mistake, so please don't do that. Please watch out for that here. Instead, we're going to multiply these. We're going to multiply the first numbers. We're going to multiply the second numbers. And then instead of creating a new vector, we're not going to have a vector anymore. We're just going to add up these two answers. And that's going to give us a number here, a scalar. And that's going to be the answer to the dot product. So let's say we take the vector 3, 4, and we dot product by the vector negative 1, 2. We would multiply the first numbers, 3 times negative 1, and then we multiply the second numbers, 4 times 2, and we're going to add up the answers. 3 times negative 1 is negative 3, 4 times 2 is 8, and negative 3 plus 8 is 5. So the answer to doing a dot product is going to be a single number, not a vector anymore. And that can be very confusing for a lot of students. It's going to turn out that it's going to have a pretty important use. We'll see in a little bit later in this video. But for right now, I just want to get down that when you multiply two vectors using the dot product, the answer you get is not a vector, it's just a single number. Now, there are, in fact, other ways to multiply vectors together that the answer would be also a vector, but those are just not covered right now in this class. It's not something for us to worry about. Just know that for us, if we're multiplying vectors, it's going to be the dot product, and the answer is going to be a single number. Now, one of the most important uses of the dot product is because it allows us to find the angle between two vectors. So if I have a vector here, v, and I have another vector here, w, and whatever angle between them, we'll call that theta, it turns out that the following formula is true. If you take the dot product of these two vectors, you're guaranteed to get the same answer as if you took the magnitude of each vector separately, multiply those answers together, and then multiplied by the cosine of the angle between the two vectors. Now, writing the formula in this fashion, maybe not that useful, but what we can do is we can solve for cosine theta, and we get v dot w over magnitude of v, magnitude of w, and this shows us that we can now solve for the angle between two vectors using this quick formula here. And that's all thanks to the dot product. So why don't we use it on the two vectors above? Find the angle between the vector 3, 4 and the vector negative 1, 2. So if we try to draw this, 3, 4 is kind of, right 3, up 4. And then negative 1, 2 looks something like this. So we're trying to find this angle between them. So we use our formula here. Cosine of theta is the dot product. So 3, 4 dot product with negative 1, 2 divided by the length of 3, 4 times the length of negative 1, 2. Well, we just calculated the dot product here. That dot product is 5. And then on the bottom here, we have the magnitude of 3, 4. We did that in the previous video. I'll remind you, square root of 3 squared plus 4 squared. So that length is 5 for the first vector. And the length for the second vector is the square root of 5. So this shows us that cosine of theta has the value 1 over root 5. Now, if I want to get the angle, I would do cosine inverse of this. And if I put this into my calculator here, cosine inverse of 1 over root 5, and I get 63.4 degrees. And so this tells us that the angle between these two vectors here is 63.4 degrees. And now you can use this to find the angle between any two vectors. You take the dot product between them, you take the magnitude of each one separately, you put it into this formula, and you're able to get the angle between them. Once again, this is a formula that I will give on my tests when I write them, but really it's one that I would like students to learn anyways, because it's just a very useful formula. You'll see a lot of classes later on, you're going to use this over and over again, and you don't want to always have to look it up. I remember myself taking a class, chemistry class, and we had something like, I think it was methane, which is CH4, and we had to get the vectors for each of these hydrogen carbon bonds, and we had to find the angle between them, and it turned out that the angle between them was important to the chemistry of how methane reacts. And so finding that angle between them was an important thing for something going on in the real world, how methane reacts with the environment. And if that angle had been different, we'd have a different situation in the world. So we found this angle, and then we can predict what's going to happen with that molecule. So it's just a formula that kind of pops up over and over again in a variety of classes, and it really is a good one to know. It's just being able to find the angle between two vectors is so great. Now, related to this, we can also determine whether two vectors are perpendicular or not. And so let's think about it. If they're perpendicular, then that means the angle between them is 90 degrees. And so cosine of the angle between them, well, cosine 90 degrees is in fact 0. So that means that the vectors v and w are perpendicular if and only if, well, if the cosine is 0, that means that the dot product is 0. And so that means we can just say that two vectors are perpendicular if you take the dot product and get the answer of 0. So it's a really quick way. You don't even have to go so far as to actually find the angle between the two vectors. You just check, is the dot product 0? If it is, then they're perpendicular. And if it's any number other than 0, then that means that they are not perpendicular vectors. So it's a nice quick check on whether vectors are perpendicular or not. And that's also something that kind of just comes up randomly in a lot of different situations. So you can see that we have a lot of uses for the dot product. There are even more out there that we're not discussing right now. This is just kind of an intro to how to calculate dot product and how to use it to find the angle between two vectors.